Welcome back, everyone. Thanks so much for watching. In this video, we're going to work out this algebra test. This is midterm 1 solutions. Feel free to work out the questions on your own first and then check your answers with mine. Let's go ahead and start. So for the first problem, we're finding the distance between these 2 points. Let's label them. Let's call this one x1, y1. This is x2, y2. So the distance between any 2 points, it's given as the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's go ahead and substitute our point. So we labeled x2 as 9. So this is 9 minus x1, that's -3 squared, plus y2, that's 0 minus 5 squared. Once you finish substituting, let's go ahead and find their values. So this will give us the square root of 9 minus -3. That's 12 squared plus, and then 0 minus 5, that's -5 squared. So let's just write it like this, 5 squared. And this will simplify to square root of 144 plus 5 squared, that's 25. And then we can simply add them up. So this will give us the square root of 169, which is 13. So the distance between these 2 points is 13. Now let's take a look at the next problem. We want to determine which, if this is a true statement, -8/11 is greater than -9/13. All right, let's see. So since we don't have a calculator, we're going to determine by algebraically. So I'm going to go ahead and multiply both sides by -1 to turn them into positive. So that will give us 8/11. When you multiply by a negative number, you have to switch the inequality. It becomes less than now over times 9/13. So now it's still not sure what this is true or not. So let's multiply both sides by the LCD. So the LCD here is going to be 12, not 12. It's going to be 11 times 13. So it's the product of 11 and 13. So once we do that, we multiply this side by 11 times 13. And this one also 11 times 13. So that leaves us with the following. 11 cancels out on the left side. We have 8 times 13 less than, here 13 cancels out, 9 times 11. So when you do 8 times 13, you will get about 104 less than 9 times 11, that's 99. Well, this is not true. So therefore, this given statement is actually false. So when you do some algebra, arrive at a false statement, of course, the initial statement was false. Moving on to the next problem. So here we want to combine these numbers by performing the operation. I'm going to go ahead and distribute. That's one way to do it. Another way is to combine these and then distribute the two. I want to distribute because I can simplify their denominators as we distribute the two. So we have 2 plus 2 times 5/8 minus 2 times 1/6. Now here we're going to reduce the fraction. 2 and 8 leaves me with the 4, and then 2 and 6 leaves me with the 3 in the bottom. So we're obtaining 2 plus 5/4 minus 1/3. And now we can figure out the least common denominator to combine, which would be 12, product of this and that. So we multiply each fraction by what they're missing. So this one, write it as over 1, and multiply it by 12/12. This 3/3, so you'll have 12 in the denominator. This one 4/4, so you get 12 in the denominator. And then this will give us 12 times 2, that's 24, plus 5 times 3, that's 15, minus 4 times 1, 4, all over 12. And now we can combine the top. 15 and -4, that's 11. So we get 24 plus 11/12, which will give us 35/12. And that is simplified answer, so we can leave it right here. Now for number 4, we're going to evaluate this expression. So let's do this first. So 8 to the power 2/3, you can write that as cube root of 8 and then square that. And cube root of 8, that's 2, so this is 3 times 2 squared. And 2 squared, that's 4, so this is 3 times 4, which would leave us with a 12. So this number simplifies to 12. Here's the next problem. This is a laws of exponents. So we're going to eliminate the negative exponent. There are different ways to do this problem, but I'm going to do it the way I think it's simpler. So I'm going to go ahead and combine the top, combine the bottom. So since they have same base, on top I can add their exponents. So this is z to the 6 plus 4. And on the bottom I can also add their exponents, z to the 5 plus negative 1. So the top we have z to the 10th. On the denominator we have z to the 4th. And now using the another laws of exponents, I subtract them, subtract their exponents. So this is z to the 10 minus 4. And that gives us our final result as z to the 6. So this is the final result for this form. Here's another problem, number 6. We're going to be multiplying and simplifying this. So if I have an expression to the second power, this means I have the same expression twice. This is 9t minus 7 times 9t minus 7. And we distribute. So this times that, and then this times that, and this times that. So this will give us 9t times 9t, that's 81t squared. 9 times negative 7, so that's going to give us negative 63t. And then we get another negative 63t. And then negative 7 times negative 7, that's positive 49. So then we add like terms. 81t squared, there's no like term. Keep it as it is. Negative 63 and t, negative 63t. These are like terms. So we have negative 126t. And 49 has no like term. So this will be our final result. All right, moving on to number 7. 7, we're going to simplify this by factoring. So we're going to factor everything. So x squared minus 36, that will factor into x plus 6 and x minus 6. And the denominator, x squared minus 16, that would factor into x plus 4, x minus 4 times. And then I just rewrite these with parentheses because they're not factorable, so you rewrite them. Now we can cancel out common factors from top and bottom. So I see I have x plus 6, x plus 6, x plus 4 with x plus 4, and the leftover is your final answer. So we have a x minus 6 on top, and on the denominator we get x minus 4. And that's your final answer for this. Now let's take a look at this problem, number 8. We're going to factor this expression completely. And I see they all have a GCF in common. So the greatest common factor is a 2. So I pull out a 2. I have x squared plus 3x minus 10. And then I refactor the inside. So this will factor into x plus 5 and x minus 2. And then just double check your answer by redistributing. So this would be your completely factored expression for that. So here's the next problem, number 9. We're going to perform the addition by looking for the LCD because we're adding two fractions. We need the least common denominator. So our least common denominator will be this denominator. So I need x plus 5 and this denominator, x minus 5. So now we grab each fraction and give them what they're missing. So 1 over x plus 5, I would multiply this with x minus 5 over x minus 5, put parentheses, minus 1 over x minus 5. I give this one x plus 5 over x plus 5. And now we can join them since they have same denominators. So the first one, 1 times x minus 5, that's simply x minus 5. The second fraction, can be careful with the negative. This is minus x plus 5 over x plus 5 times x minus 5. And here we're going to distribute the negative out to combine like terms on the numerator. So we have x minus 5 minus x minus 5 over the least common denominator. And now we can combine like terms. These will cancel out. Negative 5, that's negative 10 over x plus 5 times x minus 5. So that will be one way to write the answer. Another way to write the answer would be to distribute the denominator. So you can also say this is negative 10 over x squared minus 25. Any of these answers are acceptable. All right, now let's take a look at number 10. We're going to be solving this equation. This is a linear equation because the power for my variable x is 1. So let's distribute and clear out the parentheses. Here we distribute the 2. Here we distribute the negative 3. So this is 2x plus 12 plus 6 equals negative 3x plus 9 minus 1. And now we combine like terms. So on the left side, we have a 2x, 12 and a 6, that's 18. And then negative 3x, 9 and negative 1, that's positive 8. And we move terms around. So I'm going to go ahead and add 3x to both sides. So that gives me a 5x. And then subtract 18 from both sides. Gives me negative 10. And now I can divide both sides by 5, that leaves me with x equals negative 2. So that's our answer for this problem. If you want to check, you can simply plug it back to the original. All right, here's number 11. We're going to be solving this equation. This is a quadratic because the degree is 2. So let's go ahead and divide both sides by 4. So you get x squared is equal to 9 over 4. And now I can take the square root on both sides, but remember, you get 2 set of solutions if you do square root of a square. So we have x is equal to plus and minus a square root of 9 over 4, and this simplifies to plus and minus 3 over 2. So that is our answer for this problem. We get 2 set of solutions. Or if you want to write it out, you can say that x is equal to positive 3 over 2 and negative 3 over 2. That's another way you can write your answer. All right, so moving on to the next problem, we're going to be solving this equation. So you can multiply both sides by the LCD. So the LCD for this problem is 5x plus 4 times 2. So then this will give us, so I take my equation 5x minus 5 over 5x plus 4, and I multiply it by the LCD, which is 2 times 5x plus 4 equals, and I do the same thing on the right side as well. This is 1/2 times 2 times 5x plus 4. And now we cancel out the denominators. So this will cancel with that. 2 will cancel on the right side. So this simplifies to a nice equation. We have 2 times 5x minus 5 is equal to 5x plus 4. Here we distribute 2, so that gives us 10x minus 10 is equal to 5x plus 4. And then we isolate x. So I will subtract 5x from both sides. That leaves me with the 5x, and then add 10 to both sides. That gives me a 14. So x is equal to 14 over 5. Now let's check our answer since this was a fractional equation. Will this number make the denominator 0? We have 5 times 14 over 5 plus 4, and this will give you 14 plus 4, not 0. So this is good. So this is a solution. Here is number 13. We're going to be solving for t for this little equation. So t is trapped right in here. So I need to divide by r and big H. So t is going to be w d divided by little r big H. So that's the value for t. So here's the next problem, 14. We're going to find the slope of the line through these points. So for slope, we know the formula is y2 minus y1 over x2 minus x1. Let's label our points. This is x1, y1, x2, y2. So this would be 0 minus negative 3 over 2 minus 6, which would give us 3 over negative 4. So that is our answer. This doesn't simplify, so 3 over negative 4 is the slope. Now here's the next problem, number 15. We want to find an equation of the line through this point parallel to this line. So we need to borrow the slope from here. So you can have same slope as this line. So write it in y equal mx plus b. We have, so subtract 6, subtract x, you have 2y is equal to negative x minus 6 divided by 2. You have y equals negative 1/2 x minus 3. So we want to borrow this slope. So our slope is going to be negative 1/2, and the point is given to us. It is 1, negative 4. So the equation of the line in point slope form is y minus y1 equals m times x minus x1. So label your points. This is x1, this is y1. So our equation is y minus negative 4 equals m. It's negative 1/2 x minus 1. Clear out these two negatives, so you'll have your final answer as y plus 4 equals negative 1/2 x minus 1. So that would be the equation of the line parallel to that given line. Now let's go ahead and solve this equation, number 16. It's a quadratic because the degree is 2. So you try to factor, or you try to complete the square, or use the quadratic formula. So this is not factorable, so we're going to use the quadratic formula. So x is equal to negative b plus and minus square root of b squared minus 4ac all over 2 times a. So for this equation, a is 1, b is negative 4, and c is 1. So these are the coefficients. This is a, this is b, that's c. Now let's substitute them into our formula. We have negative b, so negative 4, plus and minus square root of b squared minus 4ac all over 2 times a. This is positive 4, so the double negative turns into a plus 4, plus and minus a square root of 4 squared, that's 16, minus 4 times 1 times 1, that's 4, all over 2. So further simplification, we have 4 plus and minus square root of 16 minus 4, that's going to be 12 divided by 2. And 12 we can simplify. So square root of 12 can be written as a square root of 4 times square root of 3, and this is going to be a 2 square root of 3. So I will simplify that. So this is equal to 4 plus and minus 2 square root of 3 over 2. And now we can separate this into two solutions. We have 4 over 2 plus and minus 2 root 3 over 2. And this simplifies to the following. We have 2 plus and minus root 3. So these are your two solutions. So I simplify the 4 and 2 and then 2 and 2. We get 2 plus and minus square root of 3. Now let's try 17. So we're finding all real solutions to this equation. So I'm going to go ahead and determine the LCD, which would be x squared plus 4. So we multiply both sides by the LCD. On the left side, it will cancel. You'll be left with the 4x. On the right side, you'll have 1 times x squared plus 4. Now let's set it to 0. So we subtract 4x from both sides. You have 0 equals x squared minus 4x plus 4. And this is factorable. So this will factor into x minus 2, which means our solution is only x equals 2. So the solution to this equation only x equals 2. And if you check, you'll see the denominator is not 0 when x equals 2. So we can claim this as a solution. Now let's try 18. So for 18, we're simplifying this expression. I'll rewrite that in exponential form. So sixth root of 7 is same as 7 to the power 1 over 6 to the power negative 12. And now I can multiply the exponent. This is 7 to the power of negative 12 over 6. Negative 12 over 6, that's negative 2. We have 7 to the negative 2. And that can be written as 1 over 7 squared by laws of exponent. And then 7 squared, we know that evaluates to 1 over 49. So this expression simplifies to 1 over 49. We're solving this equation. So I'm going to go ahead and divide both sides by 6. So 150 divided by 6, that'll give you 25. And then square root both sides. So you'll have plus and minus. X is equal to plus 5 and minus 5. So these are the two values for this equation. Another quadratic, so we get two set of solutions. So here's the last problem for this test. We're going to graph this function. We're going to, by making table of values. Okay, so let's take a look at the domain of this. So we know that this function has domain from 0 to infinity, because if you plug in less than 0, it will give you imaginary numbers, not a real number. So here's our table for the x column. Here's the g of x, which is your y values. And then you'll have your point x comma g of x or y. So let's start with 0 and then do 1, maybe 2. I want to do 4 next. And then you can keep going. So when you plug in 0 into this function, g of 0, that's 3 plus square root of 0, which is 3. So you have 0 comma 3. When you plug in 1, you will have g of 1, which is 3 plus square root of 1. That's 3 plus 1, which is 4. So you have the point 1 comma 4. And then when you plug in 2, you have g of 2. Now this is not a nice number, so you just write 3 plus square root of 2. So we're probably not going to plot this one, but it's a number a little bit greater than 3. So it's when x is 2, we get 3 plus square root of 2, something like that. And then for g of 4, we get 3 plus square root of 4, which is 3 plus 2, that's 5. Okay, that's nice. 4 comma 5. So you have an idea how the graph looks like just by looking at the table. So here's our x and y axis. So we know square root looks like this, but that's not what we're graphing. We're graphing plus 3 to the square root. So we're going to plot the points and come up with that shape. So when x is 0, we have 3. So here's our xy plane again. 0 goes to 3. Let's suppose this is 3. And then 1, 4. Maybe this is 4. And then 2 will be 3 plus square root of 2. So I'm not going to plot that, but it's going to be maybe up there. So ignore that one. The next point I'm going to graph would be 4. Perhaps here. So it'll be 5. So something right here. So you can see the shape. So not the best shape. So I will do it again. So here's the first picture. Then just keep on going that way. So something like this, roughly sketched. So this is your g of x equals 3 plus square root of x. All right, so this is the end of the test. I hope you enjoyed. Thanks for watching.